Namaste everyone. In this video we are going to solve a problem on kinematics, and the question you can see here, we haven't given the relation for acceleration and displacement, right? So this here is an equation where A is the acceleration, and S the displacement, right? And of course the units for acceleration are in meter per second square and the displacement is in meters. So this being the relation between acceleration and displacement, we have been told to find the velocity of the object when distance. So velocity we have to find at displacement equal to 100 meters. And then we have also been asked to find the distance. We have been told to find the distance when velocity is equal to 0. When you first see this particular equation, it appears that it's very difficult to solve it because acceleration is dts by dt square, and there is no time in the equation. In place of time we have displacement. That's what makes it very, very complex. But there is a workaround for this. What we can do is we can take acceleration as differentiation of velocity. Okay. And then what we can do is we can multiply and divide this by the displacement, and we can actually exchange the denominators. So when we exchange the denominators, we will have dv by ds here and multiply by ds by dt. We know the value of ds by dt is velocity. So dv by ds into velocity is what we get, and that's equal to the acceleration. When we substitute this relation here in our relation, what we get is v times dv by ds, that will be equal to 12 minus 0.1. Yes. So we just need to take the terms, like terms on different sides, and we need to apply the integration. So v terms we are taking on the left side, and s terms let's take it on the right side. Now when we apply the integration, we will get the relation between velocity and displacement. Let's go ahead and do that. Integration of v is v square by 2, and on the other side integration of 12 is 12s, integration of minus 0.1 is constant, and integration of s is s square by 2. Of course we will get another constant here as well, and for finding the value of constant we have to use the initial conditions where it is starting from rest. Okay, so the acceleration it's starting from rest, so that means initially the velocity is 0 at displacement 0. So when we substitute this relation in a particular equation, what we get here is 0 equals 0 minus 0 plus c. So that means c is in fact equal to 0. So when we substitute this relation in our actual equation here, we get a simplified equation that is a relation between velocity and displacement. Check like this. So it's 12s minus 0.1 s square by 2. Now this is the relation we have to use. This is the relation we have to use to find what is asked. So first we need to find velocity when displacement is 100. So first we need to find velocity when displacement is given. So let's find the relation for velocity, and that's going to be 12s minus 2. It still goes to the numerator, so it gets multiplied. So let's just multiply it directly. So we get 24s, and these 2 in denominator will get cancelled, and we get this like this. And of course, because there is a square here on this side, we'll have to take square root of this. That's the relation for velocity. Let us now substitute in this the value of s to be 100, so that we get value of velocity. Okay, so 24 times 100 minus 0.1 times square So we're getting 1400. So we need square root of this, and we are getting the value of velocity as 37.42. This solves our first equation. The velocity at displacement, displacement that is. Okay. Let's go ahead and find the second value. Here the velocity is given as 0 and we need to find displacement. From this equation directly, we can substitute the velocity as 0. On the left side we have 0, 12 as minus 0.1 square by 2 is what we get here. If we take yes common from this, if you send the yes to the other side, yes becomes 0, we can just neglect it. And now what we are left with is 0.1 s by 2 equals 12. So yes equals 12 into 2 by 0.1, which gives us the value of yes as 240 meters. So this here is our second answer, second bit. This is the bit, that's the A bit. That's what he has asked, and everything that he has asked, we have found it yes. So hope you have understood this problem perfectly, and in the next video we'll take up another problem.